All right, guys, I know a lot of you have questions about day one notes. So I'm going to take maybe 5 or 6 minutes here and just recap a couple things, not everything. If you didn't watch the day one note video, you need to go watch that. That's everything. But let's just do day one recap. So this is focusing on vertex form. So this isn't in your note packet or anything like that. Again, I'm just going to kind of make these questions up on the fly, and this is kind of from everybody's response on the discussion board. So these were just some things that I noticed. So I'm going to make up some problems and talk through it. Hopefully this will help some of you and clear up some of that confusion. So first and foremost, this whole unit, all the things that we're going to talk about the next couple weeks, after that, basically for a while, is quadratics, which quadratics always look like parabolas. So you have two options, or we're going to do two different types of parabolas. Ones that open up, and if they open up, that means that, down here somewhere, they have a minimum because it's a low spot. And here's some examples of questions or problems that would open up. Anything that's positive. Okay, so anything that, that the equation has a positive something in the front. And I'm just making some of these up. So there's something positive 2x squared opens up. Or something like positive 1/2 x minus 3 squared. Again, positive 1/2. That's positive, it opens up. Okay, or you have the other situation where your parabola opens down. So this is the other one we're going to talk about. If it opens down, put that on there. If it opens down, you have a maximum somewhere at that top spot where I put a yellow or red dot. You have a max point. And if you have this situation where your graph is opening downward, that means the equation, the parabola, is negative. So that means that there was a reflection. So the equations are going to look something like this. Negative 3x squared plus 6x or whatever. A negative 3x squared that is opening down. Or, again, just making these up, negative 5x plus 2 squared minus 4. And negative 5 in the front of the equation is telling us that there's a reflection, so that graph flips and it's opening down. So we kind of talked about that in the beginning of the notes, kind of about the picture and about the vocabulary and things like that. The only other thing I can add to this at this time to kind of go off of these pictures is AOS, axis of symmetry. This is the line that cuts the parabola in half. So I'm going to go ahead and just put these purple dotted lines through the middle. This is my axis of symmetry. All parabolas are symmetric. So if it's something on the left side, it's going to do the same thing on the right side, and the axis of symmetry cuts that right in the middle, right down the center line. Okay, so there's like a little bit about the vocabulary and opening up and down mins and maxes. Some of you guys had questions on that. Okay, so now here's really where people had questions on. Okay, so I'm just going to throw out a bunch of examples here. We'll just do a few things. So here's the first one. Let's do example 1 here. If I give you this problem, f of x equals negative 3x plus 4 squared. Okay, I'm going to ask you for the vertex and axis of symmetry. Let's start there. So if I have this equation, it is in vertex form because it looks like that equation that I gave you. It looks like the vertex form. So to find the vertex, you're going to do the opposite of the inside. So I'm highlighting it yellow. You see how it has a positive 4? You change the sign to make it negative 4. Always the opposite of the inside. We've been doing, remember I've been putting a star underneath there? We've been doing the opposite of that forever. And then you do the outside. The outside is this one on the back side here. So where I'm highlighting it blue, there is nothing out there. So you can almost pretend like there's 0. There's nothing on the back side. And that's how you get your vertex. The axis of symmetry is going to match the x value, the yellow part that I highlighted, that -4. It's always going to match that. So I'm going to highlight that yellow as well. That's always going to match that value. Okay, let's do another one. Example 2. Y equals 1/2 x minus 3 squared plus 9. We're going to find, just like before, the vertex and axis of symmetry. So vertex, you do the opposite of the inside. So I'm highlighting it yellow again. The opposite of -3 is +3. So change that to a positive. And then you do the same as the outside. So this time I actually have something on the back side. I have that +9. I keep it a +9. I change the yellow. I keep the blue. Axis of symmetry, which is cuts that parabola in half, is always x equals, and then it's going to match the x value, which for me is this yellow one that I'm highlighting. It'll match that 3. Okay, let's do another one, and I'm going to add on another detail here. So, example 3. Y equals 3 x minus 2 squared plus 10. Okay, making this one up. Here we go. Same thing. I'm going to add on a little bit. Let's do the vertex. Let's do the axis of symmetry. And let's talk about max and min, because I know that's on some of those papers. So the vertex is, again, opposite of the inside. I'm highlighting it yellow. I have a -2, so change that to a +2. And then do the same as the outside. On the outside, I have a +10. So I keep it a +10, and there's my vertex. My axis of symmetry is x equals, you always start with that, and it's the same as the x value. So again, I have my x value, that yellow part is 2, that'll match. Okay, min and max. The easiest way to think about min and max is to think about if your graph opens up or down. This graph is going to open up because it is a +3 in the front. It's a +3 in the front, so it opens up. So my graph looks, something like this little parabola. If your graph looks something like that, that's what I drew in the beginning, you have a minimum. The minimum is going to match the vertex. So the vertex is 2, 10. That is also the minimum. For these problems, they always match like that. This graph, if you think about this little tiny picture I drew over on the side there, this graph has no maximum. So I've been writing none. There is nothing to find. I know on the notes there are other pieces for you to find, and you had to graph it and other things. But these were the big questions that people were asking and emailing about, so I hope this video helps.